Hello my all dear students. Dear students, today we are going to discuss your next important topic, greenhouse effect. We have discussed in my previous lecture and we have completed the wiens displacement law and Stephen Boltzmann law. Stephen Boltzmann law. Dear students, in wiens displacement law, we have told you lambda m t is equal to constant. Means here we can say also lambda m is inversely proportional to temperature. Here lambda m is inversely proportional to temperature. Here constant we can choose which is known as wiens constant, and value of this wiens constant we have told you in my previous lecture 2.9 into 10 to power minus 3 meter Kelvin. So dear students, now Stephen Boltzmann law, if we want to write here what is Stephen Boltzmann law, we have told you in mathematical way. Stephen Boltzmann law was rate of heat flow from any black body is equal to sigma a 4 power of or fourth order of temperature. We have discussed and we have told you both here in my previous lecture. Now today our main focus are today we are going to discuss the in details greenhouse effect. Dear students, here firstly we want to see with the help of some example the result of greenhouse effect. In science, the trapping of heat, or physics we can say trapping of heat is greenhouse effect. Trapping of heat is greenhouse effect. Dear students, what is trapping of heat and how greenhouse effect is related to this trapping of heat? Now here we want to see. Now dear students, trapping of heat, how it is possible. Now we want to see here with the help of some example. Now here we are considering it is our sun, which is very large source of heat energy, and temperature of sun is near about 10 to power 5, and here also we are considering it is earth surface. It is earth's surface. Dear students, as we have told you, by radiation earth heats up or receive heat energy from the sun. We can show here earth receive heat energy from the sun, and it receives heat energy, and we can suppose here its temperature rises. When temperature rises of this earth surface, here we are assuming its temperature has been raised by 300 Kelvin. Now when temperature of this earth surface has been raised, then it emits energy. Then it start to emits this heat energy. Dear students, in the atmosphere many greenhouse gases N2O, CH4, CO2, O3, all these gases are present. These gases are also known as greenhouse gases. When heat energy emits earth surface, this earth surface emits heat energy due to rising of temperature of this earth surface, then it will go from this earth surface to the atmosphere, and when this heat energy will go to the atmosphere, it is atmosphere. When this heat energy will go from earth surface to the atmosphere, then it also heats up. Here what is result we have found. Firstly, the earth surface warms and it emits heat energy, and again this atmosphere receives energy, or also this atmosphere heats up. Dear students, why its atmosphere heats up? Because this heat energy is going from this earth atmosphere, this earth surface to the atmosphere. Heat energy going from earth surface to this atmosphere. So this atmosphere also heats up. Dear students, why this heat energy does not going from or crossing this atmosphere? Because here by the help of or with the help of Wiens displacement law, lambda m is inversely proportional to temperature. We have discussed in my previous lecture. When T is small, then lambda m will be large. Then lambda m will be large. Dear students, also with the help of curve we can feel it. When T is very small, then lambda m will be large. Here lambda m will be this. When again B rises temperature, then its lambda m will be small. Its lambda m will be small. Again when B increases temperature, then B shall see here lambda m again will small. So dear students, here we are seeing lambda m is decreasing. When we are increasing temperature, then lambda m is decreasing. When lambda m decreasing, but here energy are increasing. Here energy are decreasing. Here we can see T3, it is T1, it is T2, and it is T3. Here we can see from this graph T3 is very high temperature, very large temperature. We are supposing here, or we are assuming here also. T3 is very large temperature. When T3 is very large temperature, then we have seen its energy also very large. But here we have seen in my example, temperature of this earth surface is near about 300 Kelvin we have considered, which is very less compared to the temperature of this sun. If temperature of this earth surface is very less, then value of lambda m is large, and if value of lambda m is large, then dear students, its maximum wavelength, energy at this maximum wavelength is very less. We can see here if temperature is very less, which is T1, and in this case also we can relate here T1 from 300 Kelvin temperature. We can relate both. If T1 is less, then its energy is also less. If its energy is also less, then it cannot go further or cannot travel very large distance from this earth surface to the atmosphere, we can say. So it does not goes this emitting heat energy, this which are emitting from this earth surface, this heat energy which are emitting from this earth surface due to increment in temperature to the surrounding. Here we have told you this heat energy which are emitting from this earth surface to this atmosphere, both are heats up. Both are heats up means this earth surface heats up due to sun, and atmosphere also heats up due to this emitting energy from this earth surface. So this atmosphere and this earth surface both heats up, and also we can say when it heats up, it again reflect or returns energy to the earth surface. Here question is why this emitting heat energy does not goes to the atmosphere at very large distance. Then answer of this question is because from this, here we have seen at very low temperature this energy is here, this energy is very low at this lower T1 temperature, and this is also very low temperature compared to this temperature of sun. So its energy is small. When its energy is small, it cannot go large distance, or cannot travel large distance from this earth surface to the atmosphere, from the earth surface to the free space. So this energy traps between this atmosphere and this earth surface. Here what is net result? Net result, dear students, here net result is when heat energy trapped when heat energy trapped between atmosphere and earth surface, then this phenomena is known as greenhouse effect. Dear students, due to this trapping of heat in Europe or in other cities, many other cities, the houses appears as green color, because due to this trapping of heat between atmosphere and earth surface, no air can go into this at the place of this trapping of heat, at the place where this heat was trapped. No air can go into this place, so many buildings appears as green color, so it is called greenhouse effect. Its name has been chosen is greenhouse effect. Greenhouse effect means in physics, in science, we can understand only trapping of heat. So today we are going to stop here. We shall see, and we shall discuss next important topic, which is Newton's law of cooling. Thank you very much.